my name is Jean and welcome to Johnny's workshop. Today we'll be looking to this research and development, which is basically running the car with no wires. As you can see, I got two examples here. So the idea is to clear as much room as possible, and there'll be no wires, getting stuck onto the body, etc. And you get a really nice sliding motion there. And so does this one. It's very light. You can also adjust the pressure, obviously, on the stress points here. You can give it an angle, etc. And I'll show you in a second how it's done. And this is Mark 1 development, basically. It's 2-hand wires, and this is what we're going to be replacing, basically. And in the end, you'll be looking like these two. Now, the reason why I went for this type of design, it's simply because there's a design flaw here, in my opinion, because you're not meant to be soldering on these tabs. It's okay if the wires are cramped to it, but even so, there's too much stress and moving around, they will snap eventually. And this definitely stop all that problem if it's done right. So I already cleared that wire out of the way, and also whilst I was doing the other two cars, I've already prepared something. So basically I measured like this. I took more or less the width of the motor to draw this sort of legs on each end, and then there's a hole here of 8 millimeters, and this will fit around the support basically, and we'll do both sides in one go so it's symmetric, and in the end we'll be able to split. So this is how I estimated how much we needed for the car. So I'll basically count around 1 centimeter or 1.5 centimeters beyond where the guide sits, in this gap here. This is how much more, basically to the end of the car, because we need to allow enough length to bend this plate, to go and sit at the bottom, because depending on the car you're converting, you'll have a driver that gets in the way. And as a safety notice, you should be drilling on a vise, or use a hand vise, because you don't want this to slip, and cut your hand, because this is very sharp. It can cause, damage. It's just a health and safety thing. And you're going to need one of those to cut the sheet, basically. And so what I try to aim here is to make these legs 3 mil wide, and I'm gonna cut till I meet that hole there, basically. And when you're cutting, if you never use one of those, you want to lean against the flat bottom here, which is the base, and you apply pressure, and just watch out for your fingers. You don't want to do that either. So to finish off this, you can just, you know, bend to snaps, or you can file, cut, or whichever way you want. Now, before we go any further, I need to show you what happens if you bend it too much. So this is something I tried earlier and I over manipulated it, and it's the same that happens to copper wire when you're soldering, and it's why you shouldn't solder to those tabs, you know, the wires, because over time it will snap. I can feel now it's getting much harder, and it will snap at any time now. Basically, the brass gets brittle over time. Okay. So I didn't count how many times it took me, but after a dozen times it already felt hard, because it, like I said, it hardens and it snaps. So that's why I think it's a design flaw. I mean, I've seen different ones where they put the ferrite men straight onto the tab, and that's okay because they cramp it. And obviously there's no room here for that. And also another safety measure is, I mean, arguably you shouldn't be doing what I'm doing right now, because you could cut your finger. I mean, you can cut your skin. You should always try to work with a hand vise. So, you know, and sometimes to get the burrs out, I just burnish with the back of this knife. Like that, anyway. And you straighten up, you know, in the opposite direction. So there will be a smooth side and a rough side. Anyway, we can already cut here, because that's the line I drew earlier. That's another thing that could happen when you're cutting. It will jam instead of cutting. Sometimes it requires an extra tuning here, or you just hold it still against the base before attempting to cut. So when we get to this point, what we're going to need to do, we're going to need to file this excess of material here. Or arguably you could try to, well, you can do with a Dremel basically. So it doesn't need to be perfect, but it just keep an eye on the smooth side. You want to keep it as free from scratches as possible, because this is where it's going to be sliding. So that width gives me enough room to, you know, to put it there basically. I mean, this car is going to be straightforward in comparison to the, I think it was the Ferrari. It has ridges everywhere, and it was very intricate to bend around, you know, to get around those ridges. And here is much more straightforward, I can tell. So how do I aim here? When you're attempting to draw a line, look on top of it basically, and guess a sort of gap that basically you need to have, and then you go ahead and cut a bit more. and you can finalize on with a file, a flat file, for example. And if you really want to protect the area, you don't want to have any scratches, you can always put a piece of tape and remove it later. But yeah, I'll show you a way to remove scratches as well. So they'll be a bit rough on the ends. So I just take a very fine paper and I'll do the edges. So that gives us a starting point. You can see there's a nice gap. So what you want to do now is to turn over. From now you can see where you need to stop marking to bend, because we're gonna travel upwards and go up above the suspension and back down all the way to the motor. So the line I recommend to look into is basically the extremity of the hole here. It's a good line to as a reference. I use these pliers. They have no teeth, so leave as little mark as possible. And you try to, well, like I said, to keep it symmetric as much as you can. Each car will be different. It's a lot of trial and error. You can also use the plier as an idea on where to bend. It doesn't need to be perfect because they'll get split afterwards, and then you will be able to do fine adjustments basically. Now I got an idea of where we're going now. I think we can start bending from here. This guy anyway. And I'm gonna give it a sort of nearly 45 degrees. All right. The posts are going to be in the way here. So I reckon we will need to file to get around them, file some of the brass, but we'll see. Now, sometimes it can be a bit fiddly, but just be patient and you get there. I mean, this is the third time I'm doing today. Open that upwards. So this is the shape we're looking at. And what happens is now I'm going to match the motor tab, basically, by bending this one to the same angle. So this is pretty much how I want it to be. Now I'm going to work on the guide first before we split, because I need to transfer the position basically by by scoring a very light marks there, so I know how far it goes basically. And I do need to split before I solder into place, because this motor is already it's already in a way where I can't remove it. So this is pretty much what we need to perform. The tab has been made in that shape, so the contact goes against the top plate there. As you can see, it's moving on a press. And now I'm going to show you how to proceed to do that. But one thing to take into account is when you cut with these pliers, it will create a burr on one side, so bear in mind that you got to keep the smooth side, which I believe is this one here, to the outside. Otherwise you'll be rattling against it and you don't want that. So, and the width of these tabs are under 3 mil. So from this point you can sort of guess where do you need to put the pliers to apply pressure. So now I'm going to mark it to cut. Here we have it. So what we do now is to basically roll that brass till it goes over the ridge, basically. So now you got to make sure there's nothing sticking out. There's a little bit there. So what I do, I just file gently. Try not to foul the plastic in the process. But thing is, if you've done one of these, you'll be fine. But one thing is, to put it on, you need to remove the tabs. Otherwise you're not able to get in there. So you want it to go under the tab, in that bit. I'm going to burnish, so you can use a steel ruler like this one. And give a nice mirror finish to it, because otherwise you'll be only scratching rather than sliding. So that's very good. So now what we do now is we do this a few times to create a mark underneath. So why do you need to create a mark? So you know how far it goes. Just so you know how far it goes, how much you need as a contact. Because you don't want it to run across and touch the other side, obviously. So from now, you will have some marks here, or if it's not appearing, if it's not obvious, can put it back on, and you can trace a line at the end of each one. So I know that when I turn this way, it will finish here. When I turn that way, it will finish there. So now we can cut here. We're going to cut 2 pieces off. Like I say, I'm not only doing this way around because the motor is already fixed to the chassis, and I'm not able to pull it like the other ones. I think I'm going to need to clear that for the stem. And on this side, I think it's going to be the same. I'm going to trace it on each side, and I'm going to file it. You want it to give it a nice clearance so it operates properly. So at this point you're able to solder that side. So what you want to do, you want to find a really nice position moves nicely. At the moment, the tension point or the stress point is right there, so you can see how it operates from this area that is bending. So it gives you a nice lever basically. So it's not hard for things to move around. Yeah, you keep things snappy. So you can barely see, but it's basically flush to that. That's what we're aiming for. Because then when this goes against it, see, it's always in contact all the way. We can apply pressure like this. It still operates. There's plenty enough contact there. Good at distance. Let's put a screw and see. So some of the footage has been removed because I spent a lot of time manipulating and working out how things works best here. And this sort of arrangement worked for me. And so it should work for anyone really. I'm able to close it easily. I mean, I could spend more time making it even better. So this is it, all three. I'm almost tempted to do the same on a Surtees in the future, perhaps. And if you're wondering what kind of brass sheet I've used, I believe you can get that sort of material in any hobby store. Thank you all for watching and see you next time.